today I am going to discuss about the second part of redox reaction. So today we will know electron transfer reaction. Actually, this is a method by which we can know about the redox reaction, basically oxidation and the reduction reaction. So to know the electron transfer, first I will show you the basic idea about the oxidation and the reduction. When a metal, it is zero oxidation state, it is gain one electron, it will go to M minus. So here the oxidation state of metal is 0, but when it is taking one electron, then the oxidation state of metal is -1. When suppose metal is zero oxidation state, but it losing one electron, then the oxidation state of metal will be +1. So here gaining electron, here losing electron. When a chemical reaction, in a chemical reaction, when we will see there is gaining of electron, then we can say it is a reduction reaction. So it is one type of the reduction reaction. So opposite term, opposite reaction, that's mean the losing of electron, it will be the oxidation reaction. So when we will see the redox reaction in terms of the electron transfer, then we have to see where the electron is gaining and where the electron is losing. Where the electron is gaining, then it is a redox reaction. Where the electron is losing, then it is a oxidation reaction. So before going to the reduction reaction and oxidation reaction in terms of the electron transfer, again I will show you here the basic idea how we can write a metal salt in terms of the cations and the anion. Like this is the MXNY, this is the metal salt, that's mean it is a cation. M here is cation, or N the anion. So this is a metal salt, but how we can write this metal salt in terms of cations and the anion? That will be like that: X M Y plus Y N X minus. Okay, so this is the strategy or the procedure to write a metal salt in terms of the cations and the anion. So like we can write, suppose NaCl. So NaCl will be like that, Na plus Cl minus. Here sodium is 1, chlorine is 1. So it will be first here, so that's why there is the 1. So this 1, that means the number of chlorine will be charge of the sodium. So that's why it is a +1 oxidation state. Similarly, so this one will be here, so this is the 1, and the number of the sodium will be the charge of the chlorine. Similarly, we can write MgCl2. So here number of chlorine is 2, and there is the 1 magnesium. So 1 will be in front of magnesium. So 1 magnesium, and this number of chlorine will be the charge of magnesium, magnesium plus 2, then 2 chlorine minus. So in this way, we can write the metal salt in terms of the cation and the anion. Why we are writing this type in this way, this metal salt? Because when we will write the metal salt in terms of the cations and the anion, then easily we can see the oxidation state of the every element. So here the MgCl2, so here the magnesium has the +2 oxidation state. So we can see here, or we can say the magnesium has the +2 oxidation state in MgCl2 metal salt. So that's why we have to know how we can write the metal salt in terms of cation and anion. Then some basic idea when gaining of electron, when the gaining of electron in a chemical reaction, suppose their electron is gaining, okay, then we will write as a negative charge. When it is the losing of electron, loss of electron, then it will be the positive. Suppose in a gaining of electron reaction, in a chemical reaction, there is two electron, suppose there two electron is gaining. Okay, so gaining means that I will write the positive. Suppose it is a M plus 2 electron, so M has a 0 plus oxidation state, but it is gaining 2 electron, so oxidation state will be M2 minus. Similarly, suppose M0 it losing the minus 2 electron, then the oxidation state will be M plus 2. So here I have seen that when the metal is gaining, then oxidation state is increasing. When the metal losing the electron, the oxidation state is decreasing. So when the electron is gaining, that will be the negative charge, and the electron is losing, that will be the positive charge. So these are the basic idea we have to know before going to the electron transfer reaction. How in a chemical reaction, how many electrons is transferring from the one reaction to another reaction. Suppose oxidation to the reduction to the oxidation. So that I will show you here. So here is a reaction. Suppose the sodium in presence of Cl2, it is forming NaCl. So this is a chemical reaction. So this is a chemical reaction. But in this chemical reaction, I will say it is a redox reaction. That means there is one oxidation reaction, another is the reduction reaction. So these two reaction is happening in this redox reaction. But how I will know in terms of the electron transfer that in this it is a redox reaction, and what is the oxidation reaction and what is the redox reaction? So to know, I will write, so this is a metal salt, I will write it Na plus Cl minus. So here I have written this NaCl salt as a cation, as an anion. Now you see, sodium is a metal, it is not attached to another element, so we know it has oxidation state 0. Chlorine is a gas, it has also oxidation state 0. Now the sodium 0 to Na plus is going on. So in this reaction, in this chemical reaction, sodium had the 0 oxidation state, now the sodium has a +1 oxidation state. So sodium 0 to sodium +1. So to balance the charge, I will write here 1 electron, because this is 0, but it is a +1. So to fulfill the charge, I will write 1 electron extra here. So here 0 to +1 charge is transferred to 0 to +1, and 1 electron is lost. So it is a oxidation reaction. Another, this is a Cl2, is a Cl 0 oxidation state, Cl2, it is forming 2Cl minus. So 2Cl minus means here 2 electron. So here 1 electron is excess. So here I will write 1 electron. Here 1 electron is lost. That's why I have written 1 electron here. But in this reaction, 0 to -1 oxidation state is transferred. That means 1 electron is gaining. Okay, so here is gain of the electron, that is the reduction reaction. So this is the oxidation reaction, or another is it is a redox reaction. So in this chemical reaction, two reaction is happening. One is the reduction reaction, another is the oxidation reaction, and both reaction is simultaneously happening. That's why it is a redox reaction. And now the question is when the sodium had the zero oxidation state and this oxidation state is transferred to +1, then one electron is lost. So where this electron is going on? So this electron is going on to chlorine. Here we have seen that this when the chlorine gaining the one electron. So from where this chlorine gaining the one electron? Because from here the sodium is transferred to, when the sodium is transferred to the sodium +1, then it losing one electron. So this one electron is transferred to chlorine and it forms the anion. So actually oxidation reaction, in this oxidation reaction, here one electron is lost and this one electron is gaining, okay, in this reduction reaction. So these are the two reaction, one is the oxidation, another is the reduction. Both reaction is happening simultaneously, so it is a redox reaction. Another example I will show you here. Sodium in presence of oxygen, okay, it will form Na2O. So if I balance, suppose this is a 4 and it will be the 2. So this is one redox reaction. But I have to know which is the oxidation reaction and which is the reduction reaction. So similarly, just see, just I will write this product as a metal salt, as a cation and anion. So what will be the, so it will be 2 sodium plus oxygen 2 minus, because 2, so number of the sodium will be front of the 2, so that's why it is coming in front of the sodium, and this number of oxygen is +1, so charge will be the +1, and number of the sodium will be the charge of the oxygen, that's why it is O2 minus. So this is the form of Na2O as a cation and anion. Now here the sodium has zero oxidation state, oxygen has also zero oxidation state. Now the sodium goes to sodium plus, that means here losing of electron, one electron is lost, so it is a oxidation reaction, So similarly O2 minus, oxygen has zero oxidation state but it is transferred to -2 oxidation state, that means here I will show you here the 2 electron is gaining. Now the question is, actually if I balance that, so 2 electron is losing and 2 electron is gaining, so it is a reduction reaction, it is a oxidation reaction. So if I write that in a way, here actually 2 Na plus ion is forming. So actually what will be the oxidation reaction? So sodium is transferred to the 2 sodium plus ion, that means 2 electron is lost and this 2 electron will come here. So this 2 electron is coming here and it is forming O2 minus. Okay, so 2 electron loss here, 2 electron gaining here, so it is a oxidation reaction and it is a redox reaction. I am just balancing the electron, okay, not the atom here, to show how many electron is gaining and how many electron is losing for the reduction and oxidation reaction. So these are the two example. These are the redox reaction, two redox reaction, where we can see the oxidation reaction and the reduction reaction in terms of the electron transfer, where the electron is gaining and where the electron is losing. Another example, if I show you, similarly, if I show you 2A Na plus in presence of sulfur, it will forming Na2S. So in terms of cation and anion, I can write it 2 sodium plus plus H2 minus. So similarly, so here 2 electron is lost, 2 electron is lost, so it is a oxidation reaction. And here, because here the oxidation state is 0, sulfur has also oxidation state 0. So here the sulfur to minus, here the gaining of 2 electron, so it is a reduction reaction. Okay, because 0 to, we are going to the 0 to minus 2 oxidation state. So 0 to minus 2, I have told already, when it will be the minus, that means the gaining. So minus 2 means 2 electron gaining. So that's why it is a 2 electron gaining. Here the 2 sodium, so plus 1 means is the losing, but it is the 2 sodium, that means the 2 electron is losing. So it is a oxidation reaction, it is a redox reaction. So both reaction are happening simultaneously. So it is one example of also redox reaction. So here I have showing the reduction reaction and oxidation reaction in terms of the electrons, where the electron is losing, that means it is a oxidation reaction, electron is gaining, that is a reduction reaction. Okay, so but in oxidation reaction, which one is oxidized and which one is reduced? But there is some term actually in redox reaction. I will show you here. First term is oxidizing agent. First term is the oxidizing agent. Second term will be there reducing agent. Okay. Third term will be there oxidized. Okay. Fourth term will be there reduced, oxidized form actually, and reduced form. This term actually very confusing. Okay, this term actually very confusing. So I will request you that you just remember for one case. Suppose you just remember for the oxidizing agent, so it will be opposite for the reducing agent. So you first you try to remember for the one case, suppose the oxidizing agent. When it will be easy for you for the oxidizing agent, then automatically you can say what will be for there for the reducing agent. Okay, so I will tell you some tricks or the some graphical representation here, how to remember for the oxidizing agent and the reducing agent. So in terms of the oxidizing agent, what is the oxidizing agents, or what are the oxidizing agent? Oxidizing agent means this agent can oxidize another species. Oxidizing agent means it will oxidize, it can oxidize another agent, another. That means it will oxidize to another part. It can oxidize to another part. So when this agent is oxidizing another part, that means it will be reduced itself. So there are some confusing term. Okay, I will show you. Suppose, for example, 2Na plus Cl2 equal to 2Na plus 2Cl minus. Suppose this is a redox reaction. Okay, which is the oxidizing agent, which is the like that. Okay. So we know that this is the zero oxidation state, this is the zero oxidation state. So it is a oxidation reaction and it is a reduction reaction. It is a reduction reaction. Okay. So in this chemical reaction, which is the oxidizing agent? The oxidizing agent means it can oxidize. It can oxidize mean and it will be reduced itself. So it itself actually reduced. That means reduced means, that is the term, this reduced means gaining of electron. Okay, so it itself reduced, that means this agent gaining some electron from the other species. So other species will be oxidized, that is the oxidizing agent. So oxidizing agents means it will oxidize another agent and it will be reduced itself, and the reduced means gaining of electron. So from where it will gain the electron? From the other species, which is the oxidized. Okay, so here in this reaction, chlorine, chlorine, chlorine. So here the sodium to sodium plus 1. So here the 2 electron is lost. Here the 2 electron is gaining. So chlorine actually oxidizing agent. The chlorine is the oxidizing agent. Here the chlorine is the oxidizing agent. Why I am saying chlorine is the oxidizing agent? Because here the chlorine oxidize sodium 0 to plus 1 and gaining 2 electron, and it chlorine itself reduced to the 2Cl minus ion. That's why chlorine is a oxidizing agent. So here the chlorine is oxidizing agent because it oxidizes sodium 0 to plus 1 oxidation state. So when the sodium oxidize 0 to plus 1 oxidation state, then it losing 2 electron, and this 2 electron is gaining by the chlorine and it reduced to 2Cl minus ion. That's why it is oxidizing agent. So I can write here some comment that oxidizing agent means it can oxidize another agent. Okay, it will be by it itself reduced. Okay, reduced mean gaining of electron, gaining of electron, or gaining of electrons means we know that it is a reduction. Okay, so there is another trick is that when it will be the reduction reaction, when suppose here the Cl2 to 2Cl minus, so here the 2 electron is gaining, so it is a reduction reaction, so that's mean it is a oxidizing agent. So it is a oxidizing agent. Okay, so just remember that when it is a reduction reaction, so it will be the oxidizing agent. So similarly we can write for the reduction reaction, we can write for the reduction reaction, the reducing agent, so reducing agent means it can reduce another agent, so it itself oxidized. So it itself oxidized means loss of electrons means oxidation reaction. So oxidation reactions mean reducing agent. So just remember that oxidation, where the oxidation reaction is happening, that means it is a reducing agent. Here the 2 sodium plus ion, we are going to 0 oxidation state to in a plus ion. So here the 2 electron is lost, so it is a oxidation reaction, it is a oxidation reaction. So in this oxidation reaction, sodium, which has the 0 oxidation state, acting as reducing agent. So here the sodium act as a reducing agent, so it actually reduced Cl to 2Cl minus and itself is oxidized to Na plus. So this is the basic idea. This is the basic idea that I will write here. Oxidizing agent, that means that will be the reduction reaction or the reduction reaction, and the reducing agent it will have in oxidation reaction, the oxidation reaction. So these two term, actually just remember that to know easily which is the oxidizing agent, which is the reducing agent, and which is oxidized and which is the reduced. Okay, so here if I summarized, the topic here, what will be the important point that for reduction reaction and the oxidation reaction. Just remember the oxidizing agent for the reduction reaction and reducing agent the oxidation reaction. Oxidizing agent means it can oxidize to other species and it itself reduced, and reducing agent means it can reduce the other species and it itself oxidized. And also oxidation reactions means loss of electron, and reduction reaction means gain of electron. Okay, that point. And another point is when we will see the negative charge, that means gain of electron, and when we will see the positive charge, that means that this is the loss of electron. So these are the some points. Okay, so these are the some points we can easily remember for the redox reaction and for to know which is oxidizing agent, which is the reducing agent, and what is the oxidation reaction, what is the reduction reaction. So after that I will discuss some MCQ question based on whatever I have taught till now about the classical idea, oxidation number, and in terms of the electron transfer, how we can know which is the oxidation reaction, which is the reduction reaction, and what is the reducing agent, what is the oxidizing agent, and who and which species oxidized to another species and which species reduced to another species, and what we can say for that based on whatever I have taught. Based on that I will discuss some MCQ question, so it will be easy for student to know and to solve the question. So first question is, which of the following is not a redox reaction? So which is the redox reaction? So redox reactions means we know that the gain of electron and loss of electron, gain of electron and the loss of electron. Okay, gain of electron, loss of electron, that means there two reaction will be happened, oxidation reaction and reduction reaction. So burning of candle, already I have said in the first lecture, the burning of candle is a redox reaction, because in presence of carbon and oxygen it will form the carbon dioxide and the energy, that is the very essential, but it is a oxidation reaction, we know that. Rusting of iron, already I have said this iron in presence of oxygen it forms various type of the metal oxide, it could be the Fe2O3, Fe3O4. Dissolving of salt in water and dissolving of the zinc in the H2SO4. Okay, I am going to the first option, option D, dissolving of the zinc in the H2SO4. We know that H2SO4 is very strong acid and also it is oxidizing agent. So in presence of the zinc, I will come to H2SO4 in the last some question where we can see that the H2SO4 is a strong oxidizing agent. So in presence of zinc and in presence of H2SO4, so it is a strong oxidizing agent, that means in presence of H2SO4 the zinc will be oxidized to zinc plus 2 oxidation state and it will form the some salt like Zn2SO4 2 minus. So here the 0 oxidation to the plus 2 oxidation state. So here it is a redox reaction, here the loss of electron and the gain of electron is the happening. But dissolving of the salt in a water. Suppose dissolving of salt, that means the salt means the NaCl. So NaCl always be Na plus Cl minus ion. So in place of water, it will form just a solution, just dissolve. Okay, it will not react with this water. So it is not a redox reaction where there is nothing is happening. Okay, just NaCl is dissolved in the water and it will forms a solution. Okay, and it always in solution medium and salt medium, it always act as a cation and anion, Na plus and Cl minus. So oxidation state of sodium and oxidation state of the chlorine is not changed. So no electron is gaining, no electron is lost. So it is not a redox reaction. So option C is the correct answer. Second question is oxidation number of the chromium. I have already told in the previous lecture that this is one type of the transition metal complex. Here the CO is the neutral ligand. Okay, so CO is the neutral ligand. Already I have said it is a neutral ligand. So it has it always the give charge the 0. So based on that you can calculate the oxidation number of the chromium. Okay. So another question is which of the following is not a redox reaction? Again the same question is happening, but it is a very quite interesting because when we are going to this type of the question which is not a redox reaction, that means we have to know about the redox reactions, about the cations and anions, about the oxidation state and the gaining of electron, how many electron is gained and the loss. So this type of the question is very important. So here what will be the answer? So first I will option C one, the calcium carbonate. Okay, so here the calcium has the oxidation state because we know that this carbonate give the charge -2. So corresponding, suppose this is the calcium carbonate, so it will form the calcium +2 and CO3 2 minus ion. So in this way it will be dissociate as a cation and anion. So in this metal salt here, the oxidation state of the calcium is +2. So it has the oxidation state +2. Okay, but after some chemical reaction, okay, it is forming calcium oxide plus carbon dioxide. So it is forming calcium oxide and carbon dioxide. But in this calcium oxide, what is the oxidation state of the calcium oxide? Because the calcium oxide, so we know that oxygen give -2 oxidation state. So it gives the -2 charge. So it will dissociate like that, calcium +2 and O2 2 minus. Okay. So after some chemical reaction, the oxidation state of the calcium is not changed. Before oxidation state of calcium was +2. After reaction, it has the oxidation state is +2. So there is no gain of electron, there is no loss of electron. So there is no oxidation, there is no reduction reaction. So it is not a redox reaction. So it will be the answer. Another option, if I see oxygen in presence of hydrogen, it is forming water. But what will be the oxidation, but it is a redox reaction or not? Okay, so just I will tell you here, the oxygen has oxygen has zero oxidation state, hydrogen has also zero oxidation state. But in case of the water, so it is forming the water. So water, so if I dissociated the water as a cation and anion, so it will form the 2H plus and O2 minus. So O2 plus in presence of H2 is forming 2H plus ion and O2 minus. Okay, if I remove into 2, okay, just if I charge balance. Okay, so here the zero oxidation state is it has also zero oxidation state. So 0 2 it is forming 2 minus, here 0 2 it is forming 2 plus. So here actually 2 electron is lost, here 2 electron is gain. So this is the oxidation reaction and this is the reduction reaction. So both reaction is happening, that's why it is a redox reaction. Similarly here also, sodium has zero oxidation state, but here after some reactions with the water, it is forming sodium hydroxide, and we know that sodium hydroxide means sodium hydroxide. If I write down as a cation and anion, this is the sodium plus and which minus ion. So sodium has a plus oxidation state, but before reaction it has a zero oxidation state. So that means here one electron is lost. So one electron is lost. That means another way we can say in it is a oxidation reaction. One electron is lost. That means their reduction reaction also is there. So it is a redox reaction. So it is a redox reaction. It is also redox reaction. Now interesting. So here MnCl3 is dissociated as MnCl2 plus half Cl2. If I see manganese is attached to 3 chlorine. So manganese has no oxidation state. So manganese has no zero oxidation state because it is attached to the 3 chlorine. And we know that the chlorine gives a minus charge. Okay. So it has plus 3 oxidation state. If I write out, so it has the plus 3 oxidation state before reaction. Okay. But after dissociation, it is forming MnCl2. And here the 2 chlorine. Here the 3 chlorine, here is the 2 chlorine. So it has the plus 2 oxidation state. So plus 3 oxidation state is going to plus 2 oxidation state. Means that means it is a gaining of electron. Okay, it is a gaining of electron. You have 3 valence cell. Suppose you have 3 valence cell. Okay, you have the 3 valence cell. Now you are donating 1 electron here. So number of valence cell is equal to plus 2. That is happening here. So here is the gain of electron. That's mean it is a reduction reaction. So another way, there is some oxidation reaction. So it is a redox reaction. So these 3 are redox reaction, but this is not a redox reaction. So option A is correct answer. Now question number 4. This is very interesting. 3Br2 plus 6 carbonate in presence of water, it is forming Br minus, BrO3 minus and HCO3 minus. Here the option is bromine is oxidized, carbonate is reduced. Bromine and carbonate. So just I have to see the oxidation state, bromine is 0, but after reaction oxidation state is -1. Oh, so 0 to -1 is, so 0 to -1. Just see the oxidation state, it is going to the 0 to -1. So it is the gaining of electron, gaining of electron. It is a redox reaction. So it is a redox reaction. So it is a redox reaction. That means bromine is oxidizing agent. That means bromine is oxidizing agent. So bromine is oxidizing agent means it can oxidize another species, but itself it will reduced. Itself it will reduced. So it will be not answer because bromine is oxidized. So it could be answer bromine is neither reduced nor reduced. So it is not answer. Bromine is both reduced and oxidized. So it will be not answer. So bromine is reduced and water is oxidized. This is the fact na. When the bromine is reduced, that means there is another species which is the oxidized. So water. So water is oxidized here. Okay, just simple see the oxidation state of bromine is changing 0 to -1. So it is a reduction reaction, gaining of electron, that's mean reduction reaction. That means bromine is oxidizing agent. Bromine is oxidizing agent, that means it itself the reduced. Okay, so bromine is reduced. So option B is correct answer. Now the most powerful oxidizing agent among this is the H2SO4 will be the answer because okay, so it is a very interesting question. How we will know which is the most powerful oxidizing agent and which are the most reducing agent. We know that oxidizing agents means it can oxidize another species and it itself reduced. So it itself, just term it, it itself reduced. It itself reduced means gain of electron. Oxidizing agent means it will oxidize another species but it itself reduced. Okay, so that means it is a gain of electron. So when it will gain electron, when it will have a positive charge, suppose the metal has the positive charge, suppose metal has the +2 oxidation state, then it gain the electron and then in the form the this one. So when it will gain the electron, because when it will have the +2 oxidation plus charge, then it will, then it can the gain electron. So this is the fact. Okay, so here the H2SO4, if you see, it as a acid also, and it has also strong oxidizing agent, and it will, why I am saying that, because here is the actually 2H plus ion and SO4 2 minus ion. So it is a most powerful oxidizing agent, and it is a most powerful acid also. So in this way we can decide oxidizing agent means it itself reduced, that means gain of electron. The gain of electron, that means it will have vacant cell, it will have the positive charge, then it can gain electron. Another question, uh, consider the following reaction: zinc plus copper plus 2, zinc plus 2 and copper with the reference, which is the correct statement. So here the zinc is reduced to zinc plus 2, zinc is oxidized to zinc. So just I will know that. Okay, so zinc is 0 oxidation state, here copper is 0 oxidation state. So zinc goes to zinc plus 2, copper goes to copper. Okay, so zinc, when zinc to zinc plus 2 is forming, that's mean it is oxidation reaction and it will be the reduction reaction. Okay, so from that clue easily we can say what will be the answer. You guys just find out the what will be the answer from the tricks. Now the second 7 number question is, 2 silver is in presence of H2SO4, because H2SO4 is a strong oxidizing agent, it will form Ag2SO4 plus H2O plus SO2. Already I have said it is a oxidizing agent, but as well as it is acid. So that's why option D would be the correct answer. So another question is, the reduction never involves. We know that also. Never involves gain of electrons. We know that reduction means the gain of electron. Okay, and when the electron is gained, that's when oxidation state will be decreased. Okay, so that will be the answer. That will be not answer actually. That is the positive point for the reduction reaction. And loss of also electron. Loss of electron is, we know that the loss of electrons means the oxidation reaction. So that will be answer. Decrease in the valency of the positive, and this is the main point, the decrease in the valency of the electropositive component. That is the fact actually. When the gain of electron, that's mean reduction reaction. When the electron is gaining, that's mean the decrease of oxidation state of the metal will be decreased. That means the decrease in the valency of the positive oxidation state. Now the question is 9. Now the question, oxidation state of the sulfur in this anion is following the order. Oxidation. Okay, look, we have to just calculate it, the oxidation number for the sulfur in each case. Okay, just calculate it and just see which has the positive, higher positive oxidation state. Okay, that will go for the oxidation reaction, because we know that for oxidation reaction there is loss of electron. That means which sulfur will have more positive oxidation state, this sulfur will go faster in oxidation reaction. Just find out what will be the answer for that. Now when the KMnO4 act as a oxidizing agent, ultimately forms, when the KMnO4 is oxidizing agent, that means it will oxidize another species and it will itself reduced. That means itself reduced, itself, just write down, itself reduced that means the gain of electron. Okay, this is actually reduction reaction. Okay, so here what will be the oxidation state of manganese in KMnO4? It will be +7 oxidation state. Just you calculate, potassium is +1, oxygen give the -2, so there will be -8 +1 equal to +7. Okay, so manganese has a +7 oxidation state, but it is a reduction reaction. When it acts oxidizing agent, so it is a reduction reaction. That means +7 to it will go to +5, +3, +2 like that. It will not go +8, +7. When it will go +7 to +10, +12, that means the oxidation reaction. So, but it acts a oxidizing agent. That means the reduction reaction. Reduction reaction, that means oxidation state of the metal, here the manganese, will be decreased. Just calculate what will be the oxidation state for the manganese, what will be oxidation state for that case, and that. Okay, see, uh, uh, it is a +7 oxidation state and it is forming +2. So I just write down here manganese +7 to manganese +2. So there is difference is +7. So there is difference is +5. So I have to give 5 electron here. Okay, because there is 7 valency cell. So there is 2 valency cell. So if I give the 5 electron to the 5 valency cell, so so manganese will have the +2. So it will be the charge balance is here. So when we are giving the 5 electron, then the charge of the manganese is balanced. So when it is going to the +7 to manganese +2, then the number of electron is transferred 5 electron. So that will not answer, that will be not answer. So between that will be the answer. Just you guys find out for the another case. It will be the very easy. You just calculated the oxidation state of the manganese and just see how many electron is transferred. Okay, how many electron is needed to balance the charge of the manganese. Another 2 question is remaining. Just I will show you here. This is a very important question. Oxidation state of the chromium. Look, already I have told in the previous class that CO is a neutral ligand. CO is a neutral ligand. Okay, CO is a neutral ligand. Similarly, phosphine. This is the phosphine type of ligand. Triphenyl phosphine. PPAS3. It is also a neutral ligand. Okay, it is also a neutral ligand. And we know that neutral ligand, that means it gives the charge 0. So it will give charge 0 and it will also give the charge 0. That means chromium will have 0 oxidation state. Now, which of following is not a reducing agent? Look, it is not a reducing agent. That means it acts as a oxidizing agent. It has oxidizing agent. So it acts as a oxidizing agent means it can oxidize to another species and it will be the reduced. That means for that oxidizing agent, reduction reaction will happen. Reduction reaction is happening. That means gain of electron. So here I have to see which have more positive charge. Okay, which have the more positive charge. Look, for the NO2 minus. Okay, here nitrogen has, if I see it has +2 oxidation state. Carbon has the CO2, the carbon has +4 oxidation state, and H2O2 this that will be have 2 plus positive oxidation state, and SO2 also have SO2 oxygen always give the 2 minus. That means there is the 2, though sulfur is also +4 oxidation state. So that will be the answer and that will be the answer. But which is the most good oxidizing agent act as the carbon dioxide? Because when we are going to the SO2 minus to the CO2, if I compare to the SO2 minus and the CO2, there is change the sulfur and the carbon. Okay, so and the sulfur and the carbon, between that SO2 is going act as a reducing agent but for that carbon dioxide it can go for the another, there is have some reduced form of the carbon dioxide, but for case of the SO2 there will not have the any other reduced form. That's why carbon dioxide will have the answer here. It is not a reducing agent, it is a oxidizing agent actually. So carbon dioxide is not a reducing agent, it is a oxidizing agent. So these are the 12 question here I have discussed, and some question I didn't say any answer, and but I have told the some tricks to calculate and to know the answer, what will be the answer. So you guys, the remaining question you guys just try it, and if you have any question you can ask me in the next class. Okay, thank you.